Welcome to Subnetting a Little Bit. Today's session relates to the Subnet Address Map. We will examine the following: a closer look at the address map, a quick review of the classful address map, the Subnet Address Map, the information that can be extracted from the Subnet Address Map, examples of the Subnet Address Map, the steps to determine the Subnet Address Map from a given IPv4 address. And finally, we'll look at one example. For more examples, see the next video. We use the term address map as a generic term, but in this series, we deem there are two variations: the native address map and the Subnet Address Map. The native address map is used to represent classful addresses. These are addresses that have not been subnetted. The Subnet Address Map is used to represent classless addresses. These are addresses that have been subnetted. We may simply use the term address map to refer to either one, but most often it will refer to the Subnet Address Map since it is the more interesting of the two. Recall the address map is used to represent the type of bit in an IPv4 address. This includes both network bits and host bits. All 32 bits in an IPv4 address must be represented. Uppercase letters represent 1 octet, or 8 bits. Each lowercase letter represents 1 bit. Here is a quick review of the native address map. Recall the class is determined by the range of the first octet. Class A addresses have one classful octet. It is represented by using an uppercase N in octet 1. Class B addresses have two classful octets. They are represented by using an uppercase N in each of the first two octets, octet 1 and octet 2. Class C addresses have three classful octets. They are represented by using an uppercase N in each of the first three octets, octet 1, octet 2, and octet 3. Here we see how the network bits represent the network portion of the address, and the host bits represent the host portion. This series uses the address map as a tool in the subnetting process and to analyze IPv4 addresses. It can be used to extract all of the information noted here. We will eventually cover how to obtain this information. These are examples of a subnet address map. Note the following: the number of uppercase N's mapped to the native class of the address. The prefix length maps to the number of network bits. The total number of network bits plus host bits equals 32. We now explain the steps used to determine the subnet address map, followed by an example. First, identify the native class of the address. We do this by considering the value in the first octet. This allows us to specify the correct number of uppercase N's in the address map. The second step is to borrow some host bits to convert them to subnet bits. Use a lowercase s for every bit borrowed. When host bits are borrowed, they become subnet bits. Once again, we emphasize that subnet bits are network bits. Borrow enough host bits so the total number of network bits equals the prefix length. The total number of network bits includes the classful octets plus the subnet bits. The last step is to add enough host bits to account for 32 bits. We'll do one example in this episode and additional examples in the next video. Given the address 10.2.3.4/11, determine the subnet address map. By the way, the given address could be a network address or a host address. In either case, the address map will properly resolve. Step 1 is to identify the native class of the address. Since the first octet is 10, this is a Class A address. so we will use 1 uppercase N. In step 2, we borrow enough host bits so the total number of network bits equals the prefix length. The prefix length is 11, so we need to borrow 3 host bits, thus converting them to subnet bits. The 8 network bits in octet 1 plus the 3 subnet bits in octet 2 adds up to 11. This equals the prefix length. Step 3 is to add enough host bits to account for 32 bits. In this case, we add 21 host bits by adding 5 host bits in octet 2 and use uppercase H to represent 8 bits in each of the last 2 octets. 1 classful octet, or 8 bits, plus 3 subnet bits, plus 21 host bits, adds up to 32 bits. And that's it. We are done. This is the subnet address map for the given address. That's it for now. Thanks for watching. And remember, nothing worthwhile comes easy. So go forth and subnet a little bit.